Hello. Microcontrollers simplified. Once we talk about microcontroller, people, those who are new to it, or some people who are interested in electronics, they feel that it's a high-tech product and we are not the people to understand about it and we will not go about it. Let me tell you, this, although it is a high-tech product, people have only made it complicated, calling it's a very high-tech product, and electronics, people who have interest in electronics are scared to go more detailed about it. The objective of this video is to clarify that doubt, and so that people, those who have zero knowledge or little knowledge, will be able to use microcontrollers also. We have taken a typical microcontroller here. It's being manufactured by many companies, but then we have taken a microcontroller from the Atmel series. Atmel is a company from the Atmel series, and it's called the family of microcontroller. 8051 is the most popular, and it is used almost about 70 to 80% of the microcontrollers used are Atmel series, 8051 series. It's 8051 series I call. It's the generic name, but then the actual numbers will vary depending on the features inside. It is sometimes called 89C51, 89C52, 89S51, 89S52, and so on. And the 20 pin IC also, it's called, this is a 40 pin, there's a 20 pin also, 20 pin called 89C50, 89C2051, like this sort of things. But then all said and done, they are all microcontrollers, and unless they are programmed, it's a dead component. It can do nothing. Program means we have to write a program in certain language. Let's say, for example, C language. They call it embedded C. It's an extension of C. An embedded C language, we write a program, and in that program, we'll see what is that program later on, but then let's see, it requires a program. And we write a program, and then we convert it to machine language, because this microcontroller cannot understand the English language or C language. So we convert it to machine language. That machine language is called .he hex file. How we do it? We use a cross compiler. We call it a compiler. Let's not get put off by the word compiler. It's not nothing but a simple software, and then it could be a Kiel software. And in that Kiel software, once we write that program, we convert it to the hex format, and that hex format, through the programmer, we use a programmer. This is the IC. We take this IC to a programmer, put it on that programmer, connect it to the computer, and then download that hex format onto this microcontroller. And then it becomes a product to be used. Otherwise, it cannot be used. We will not go into more details about the programming part of it. Let's think it's like a calculator, something comparing to a calculator. What we do in a calculator? I press 2 plus 2, I get 4. What is happening inside, I'm not bothered. So similarly, we should know what we give and what we get, and that is what is a microcontroller. Before going into that, the use part of it, let me talk about the few other features, few other important parameters which is necessary for somebody to know. There are a standard 40 pin is the supply, 5 volt. We have to give 5 volt because this operates on 5 volt. We have to use some regulator like 7805 and all, give a 5 volt here, and this is the ground pin, 20 pin. Then 18 and 19, pin number 18 and 19 are meant for connecting a crystal. This is a crystal. That crystal is meant for the internal oscillator to oscillate at that frequency. If this crystal is 10 megahertz, this will oscillate at 10 megahertz. This is 20, is oscillate 20. Typically, a crystal of 11.0593 is used, and that the crystal will oscillate. The internal oscillator will oscillate at that particular frequency. So why we need a crystal oscillator? A crystal, and then it's not a crystal oscillator. It is just a crystal. The oscillation takes place inside the microcontroller. It is because you see this gives an oscillation frequency. Okay. Many times the controller requires certain timing reference. What is timing? Timing means certain some program requires timing. For that, or even the entire operation inside the controller requires timing operations. So since t is equal to 1 by f or f is equal to 1 by t, we know. So unless I give a frequency reference, I cannot derive a time reference. And that is how the time reference comes for internal use and for many more use. Then you got a 9th pin. The 9th pin is called the reset pin. In this reset pin, we have connected a capacitor in this fashion and a resistor in this fashion, positive and negative. The reason being that the moment we switch on, what happens? This capacitor starts charging. Charging means this point immediately goes to high, because the capacitor originally was in a discharge condition. Once it immediately goes to high, this pin goes to high. After some time, when the capacitor stops charging, this point goes to low. That means initially this point will go to high. After some time it will go to low. You know what is that time? The time is very small into the time constant of RC. That means it could be about, say, some milliseconds or even microseconds. And you will not even notice that. The reason is why we take this point initially to high and then to low is to the program which is there inside will start from the beginning. Otherwise, the program may start somewhere arbitrarily from anywhere. Then we also have provided a push button switch here. In the event of the user desires to start the program from the beginning, he can press it, but usually this is not required. Once you press it, again the same thing happens. The capacitor gets discharged and then it starts charging. This point goes to high and then goes to low. So this point is immediately made high once and low, so that the program starts from the beginning. In certain other microcontrollers, the arrangement is perhaps just reverse. Like for example, you take a PIC microcontroller. There are different type of microcontrollers, as I told you. The arrangement will be just reverse. The capacitor will be here, the resistance will be here. Let's not go into more that, but then this is a must for any microcontroller. Then there are ports. We call them port. Port means they are input output ports. They can be used as input, they can be used as output. Okay, so this is called port 0, port 1, port 2 and port 3. Port 3 has got certain extra features. Like even port 2 also has certain extra features. Port 0 also has certain extra features. But let's talk about only the normal features of input output. We will talk about the input output. We'll not talk about certain extra features like some RX, TX, timer 0, timer 1, interrupt 0, interrupt 1, timer 0, timer 1, like this sort of things. They are used for a specific purpose. That is the job of the programmer. How to use them is the job of the programmer. As a hardware personnel, if you do not want to go into details of the programmer, programming doesn't matter. Depend on some programmer, ask him what to do, what you want. He will write a program for you and load this on this, and this will start working. Okay, before that, let's go into certain port pin configurations, which is important. See, port 0 is having an open drain situation. You know what is open drain? Open drain means the outputs are all having MOSFETs. Okay, that's why I have shown it here. The outputs are having MOSFETs. Let's say, for example, pin number 36. The pin number 36 is coming out from the microcontroller in open drain condition, compared to pin 17, which is coming out with internally pulled up resistor. You see, this is inside the microcontroller. This is inside the microcontroller. This internally pulled up. Pulled up means there is a resistor which is connected to positive. That's the great arrangement. They call it pulled up. Our electronics good friends, they call it pulled up. I don't know where they pull it up. Anyway, so this is called pulled up. That means this particular pin, that pin number 17, can source. Source means current can flow this way. It can flow this way. That means when this is switched off, the current can flow this way. If it is switched on, the current can flow this way. But whereas in this case, port 0, the current can only flow this way. That is, it can only sink. It cannot source. In order to source it, we have to use some external resistor here, so that this can source this way. Not through the microcontroller, but through the external resistor, it can source this way. That is the only difference between all the ports other than port 0. This happens only with port 0, not for all these 3 ports. These 3 ports are all pulled up like this. So this is what is the pull-up arrangement as far as the port 0 is concerned. It is necessary sometimes to have a open drain situation where you can use it for your purpose. Now let's come to the programming part of it. Programming, I have already dumped the program on this microcontroller, writing a program that when I give this pin number 1 a logic 0, we know logic, okay? When I give a logic 0, this pin number 21 will go logic 1, or vice versa. When I give logic 1 here, this will go logic 0. Now this is so simple. I have just written a very simple program that when this becomes 1, this becomes 0. When this becomes 0, this becomes 1. And now let me use it. I take this one logic for some purpose and then start using it. It's a very simple way that I have explained. But then there are many complicated programs can be written so that you can achieve it accordingly. Now see, if I make it 1, this becomes 0. If I make 1 as 0, this becomes 1. 1 means it goes to 5, positive, 5 volts. Typically not 5 volts, it will be about some 3 point something, 3.5, 3.4 volts. 0 means 0, it is ground. So, anytime I get any logical input, I get this logical output. This is all that the microcontroller does. It takes logical input and gives logical output in various shapes and size and forms, but the basic concept remains this. I hope I have tried to make it understand in a simple manner, but truly speaking, the program is not so simple. It requires quite a bit of understanding if you would like to write your own program, and then if you are confident about the program writing, you are the master of the microcontroller. Thank you.